welcome to lecture number 46. So, today in this lecture we will wind up the issues related to the three body problem. So, we are going to discuss about the generalized Lagrange solution, but obviously if we try to work out the whole thing, it may take at least 6-7 hours to discuss the whole content, and we do not have that much of time. So, for half an hour whatever I can discuss, and rest of the materials, as I told you earlier, I will give you as handouts. In the soft copy I will supply for that. There exist cases does not change. There exist cases where the geometric form of the three body configuration does not change, although the scale can change and figure can rotate. So, figure can rotate, this is in the inertial frame, not in the synodic. The scale change will be visible in the synodic frame, and also in the inertial frame, but figure rotation, this is applicable to the inertial frame. So, already we know that the synodic frame is rotating, and therefore, obviously, the earlier case also, if you have seen that in the earth moon system, in the inertial frame, the L 4 and L 5 and all other points, they will be rotating, but simultaneously there is a scale change involved. So, here in this case, the L 1, L 2, L 3, L 4, L 5 we got, these were the stationary solution. So, these were the stationary solutions, but what we are discussing here, this in the generalized solution, there is change of scale. So, this figure will not remain on the same scale, but rather it will expand. So, if this is mass m 1 and somewhere the mass m 2 is there, so this figure is not going to be the same, this is bound to change, and this is what in the generalized solution we look for. So, here in this case, this particle distance between this particle which is fixed here, this also will change, m 1 and m 2 distance, that also will change. So, particle in one case, the particle are at the vertices of an equilateral triangle, still it is equilateral triangle, but the triangle is expanding, it is expanding like this. So, obviously, if you have mass m 1 here, mass m 2 here, so this is mass m 1, this is mass m 2. So, distance between these masses also it is a changing. in another solution they are collinear. Lagrange showed that the three particle system, as we have been discussing earlier, three particle system of arbitrary masses here we are not putting restriction on the mass m3. This is the difference from the previous stationary solution that we were considering. Lagrange showed that the three particle system of arbitrary masses could exist in such solution as mentioned above. Under what condition? So, the conditions under which this will happen, those conditions I will be, once I supply those soft material, soft copy of the derivation. So, in that you will find, I am not going to derive all those things here. The resultant force on each mass pass through the center of mass of the three particle system, three particle or three body system. So, what it is telling, that resultant force on each mass passes through the center of mass of the three particle system. So, if we have three particles here, so on each mass, the center of mass may be located here. So, on each mass the force acting, it passes through the center of mass like this. This is your center of mass here, this is center of mass. So, this is what the first statement says, and all these things can be derived, that if we are looking for a solution. So, if we are looking for solution where the geometric form of the three body configuration does not change, but the scale change can take place. So, for that case this is applicable. While considering the stationary case, so the mass m, which was the tertiary mass or the third mass, its mass was assumed to be negligible. So, that it does not affect the mass m 1 and m 2. While here in this case all the three masses are important, and as written here they are of arbitrary three particle system of arbitrary masses. Okay. So, these are the some of the important points. Then the resultant force on each mass should pass through the center of mass of the three particle system. If this happens, condition 1, then the condition 2, the resultant force was/is force is directly proportional to the distance of each mass from the center of mass of the system. So, that means, if this is the center of mass here, say this is the center of mass and there are 3 masses located. So, resultant force acting, let us say this is mass m 1. So, force acting on this is F 1. So, this will be directly proportional to the distance of the mass from the center of mass, and if this distance we write as r 1. So, this implies that F 1 will be proportional to r 1. This also can be derived if you have to maintain the configuration, provided the scale can change. And the third one, this is the initial velocity vectors were proportional in magnitude to the respective, the initial velocity vector to the respective distances of the particles from the center of mass and mid equal angles with radius vectors to the particles from the center of mass. So, it says that the initial vectors were proportional in magnitude to the respective distances of the particles from the center of mass. Means the center of mass is located here, particle m 1 is here. So, the initial velocity vector were proportional in magnitude, means if this is the velocity vector. So, v 1 magnitude is proportional, were proportional in magnitude to the respective distance. If this distance is r 1, so this is applicable here, and made equal angles with the radius vector to the particles from the center of mass. That means, if this is m 2 and this is b 2, so these angles are equal. If I write this as alpha 1 and this angle as alpha 2, okay, similarly alpha 3 for the third particle. So, all these angles are alpha 1, alpha 2 equal to alpha 3. These angles are equal, which is being made with the radius vector. Okay. And with a comprehensive treatment, all these things can be carried out. So, shape of the configuration remaining same implies, let us say that this is the center of mass, we have particle m 1, m 2 and m 3 here. So, this is m 1, m 2, m 3 and this is the center of mass. This vector we write as r 1, this vector we write as r 2 and this vector as r 3. Okay. Then this vector we will represent by r 1 2 and similarly r 1 3 we can represent like this, from this place to this place this is R13, this is your R1 and here this is R13, this vector is R13. Okay, the same way R23 can be shown. So, R23 from this side to this side, going from here to here. This green one I am showing as R23. So, configuration remaining same, it implies that R12 divided by R120, this should be equal to R23 divided by R230 and R31 or R13 for configuration shape to remain the same. This is the condition which is required. And thereafter another condition will be required, that if the shape also has to be maintained, then the rotation rate of this about the center of mass, this is the center of mass O, say. Okay. So, this is, if we write this one as the theta 1 dot, this we write as theta 3 dot and this as theta 2 dot. So, theta 1 dot equal to theta 2 dot equal to theta 3 dot, this must be equal to the same. If that happens, that means the angle between all of them will be maintained. This angle will remain same. Okay, and thereby the configuration will be maintained. If this rate becomes different, so no longer the shape can be maintained. So, this is another condition. So, using these conditions we will be able to, we can work out all these things. So, in great details I will supply all these materials once the course runs, but right now it is not possible to cover this because of the constraint on time. Okay. So, using this we can get the collinear solution also and triangular solution also, and whatever the stationary solution we have got, the L1, L2, L3, L4, L5, the earlier we have discussed, it is just a special case of what I am talking here right now. Okay. It is a much more generalized case for the 3 body problem. So, so in the case of the generalized 3 body problem, so we have to put certain constraints. So, as earlier it was told that under certain constraint only it can be solved, otherwise it cannot be solved 3 body problem. Okay, and that too we study the generalized property of the system. We do not look into the explicit solution. Then I have also stated that stability of these points. So, stability of the, it can be a stability of the generalized point, it can be a stability of the stationary points. So, but if we consider here in this case, while I supply you, we will be only discussing about the stability of the points L1, L2, L3, L4 and L5, what we have discussed earlier for the stationary solution. And in that case we got the solution as x double dot, if we recall the equation, x double dot minus omega square, this was y minus 2 or this was plus something. Let me refer back. this was omega square x, the first term is omega square x and minus 2 omega y dot, and on the right hand side we had mu 1 by r 1 cube and similarly for y dot we had the equation omega square y plus 2 omega x dot r 1 cube y minus mu 2 by r 2 cube y, and for the z we had so in this equation this is non-linear second order differential equation, non-linear each of them. Okay. So, to solve this and to study the stability, what we do that we linearize the system. We study the stability about certain operating points. So, here in this case our operating points will be L 1, L 2, L 3 and L 4, L 5. Okay. So, if the system is disturbed from, let us say this point is L 4. So, if it is disturbed in the neighborhood of this point, so whether this will get a tendency to return back to its original position, or it will orbit around this point, or it will go away from this point. So, this will decide whether the system is stable or not stable. Okay, and for that we need to linearize each of the equations. And that representation, you know that this was written in terms of the potential function also. The right hand side was written in terms of potential function. So, we can express this in terms of potential function, and thereafter we can expand and say the if x is the original position. So, x is a deviation from this if we indicate it by alpha. So, or say the x 0 is the original position, and from deviation from this we write it by alpha. So, this is the perturbed value, perturbed position. Similarly, the y we can write as y 0 plus beta, and z we can write as z 0 plus gamma. So, alpha, beta, gamma, these are the perturbation in x 0, x, y and z. Okay. So, if we do this, then the linearized equation it can be written in terms of like the alpha dot minus 2 beta dot, assuming omega equal to 1. Okay, and this can be taken on this side, and it can be whole thing can be represented in the potential function form, which we have done earlier. Okay. So, if we follow this particular procedure, so this can be expressed, the right hand side can be expressed in terms of the derivatives of the potential function, like dou u by dou x, and it is a higher order derivatives. So, this part I am not going to extend any more here. I have just given you the introduction or just an idea what can be done. So, using this procedure, this problem can be solved, and once you solve it, so what are the conditions for stability to exist you can obtain. Okay. So, for stability to exist, mu, which we are write as mu star, actually mu we are using all the time mu star notation for M 2. okay, normalized value. So, if this quantity is less than 0.0385 and perhaps this quantity is 1 by 26. Yes, this is 1 by around 1 by 26. So, if mu star is less than around 1 by 26, the system will be Lagrange points. Stationary points means equilibrium points. Okay. By definition, I have written that the equilibrium points are stationary points. System of stationary points will be stable if this condition is satisfied, and this you will get while I supply the material. So, in the case of the say the Sun Jupiter system, mu star is around 0.001, which is less than, hence stable Lagrange point exist, and what those points will be? This will be L 4 and L 5. L 1, L 2, L 3 they are not stable. For Earth Moon system, mu star, this is nearly equal to 0.01, this is again less than 0.0385, hence L 4 and L 5 correspondingly will be stable. And in fact, in the nature around L 4 and L 5, a number of particles they exist. Okay, so, those details I will not be writing here. You can get those materials in the soft copy, because it will take time writing all those materials, but this what we get that for the Earth Moon system, this L 4 L 5 is stable. For the Sun Jupiter system also this is stable, and for the Sun Earth system, here the Sun is there and the Earth is there. So, Earth mass divided by m Sun plus m Earth which equal to mu star. This may be of the order of 10 to the power minus 6. That means, this is much smaller than 0.0385. Hence, the Sun Earth system also contains L 4 and L 5 stable points. And in the nature, as I told you, the Trojans they are there in the Earth Jupiter system, the Sun Jupiter system around the L 4 L 5 points, and also for the Sun Earth system for the collinear solution also there are very gaseous particles, very small particles, they also exist, okay, and these are very small particles. So, and can exist around the point L 2, and these points they are visible in the night sky, because once the sun rays falls on them, okay, sun rays once they fall on them. So, it is a visible, though it is unstable. Okay. But once the gas particles they are trapped here, even though unstable, these are very small particles. So, they become visible. So, it is considered as if this is sun. So, it appears like a mirror image of the sun here in this place, because the rays from the sun it is reflected back to the back, and then from the earth it is visible. Okay, so, these details I will not consider here, and I will give you written material for that. Okay, so, I will close this discussion about the Lagrange points, its stability, other issues at this stage, and whatever the extra things are required I will supply, and those material based on this already so much of things we have developed. It is just mathematics, you can go through that, and some of the written materials will be there, you can study, you will get to know the what is the related reality. Thank you very much.